Hey everyone, it's Chad here. Today we're tackling the LeetCode problem, longest consequence sequence. I'll walk you through how I'd solve this in a coding interview, from understanding the problem and devising a plan, to coding, testing for errors, and evaluating time and space complexity. I'll be solving in Python and I'll think out loud and ask clarifying questions, just like in a real interview scenario. Let's get started. First of all, let's go through the problem statement. So, given an unsorted array of integers nums, return the length of the longest consecutive element sequence. And you must write an algorithm that runs in O(n) time. I'm not sure to understand length of the longest consecutive element sequence. Let's first go through the given example to better understand the problem. So I'm given these numbers. I do have a few questions here. So can the numbers be positive and negative? Do we have any constraints on them? Well, we can see that they can be positive and negative. And the numbers, we also have some other constraints here given. So they are between, so the length of nums is between 0 and 10 to the power of 5. So, okay, nums can be empty. So what do we mean by length of consecutive elements? So let me look into the output. We have 4. 4. The explanation is that 1, 2, 3, and 4 is the longest consecutive element. So, okay, so as soon as we have the numbers in here, 1, 2, 3, 4, it means that we take them in count. Okay, so the order does not matter. So what matters is, are they present or not in nums, right? Okay. So let me go through this. And so whenever I'm looking into one number, I want to know if nums plus 1 and nums minus 1 are there. That's one thing to note. And one other thing to actually I want to pay attention to is that I do not want to have calculate. So we will have start, end, and intermediate values, intermediate numbers. How can I know if some is the start, end, intermediate numbers? So actually, I think, yeah, if nums minus 1 does not exist, for example, then it means then it's the start of a sequence, right? Yeah. So for this, as the order does not count, I think the right way to proceed is to use a set. I'll use a set. Then I'm trying to devise a plan here. And then I can iterate over the elements in the set, and I can move this way. I can move, first of all, if start of a sequence, I can loop until the end of the sequence, that is and count. Right, yeah, I can do this. So I do have a plan now. Let's now do this. So first of all, nums, I just want to store them. So I want to get, so I can call nums actually, the set elements, maybe for elements of the sequences, and then I can iterate over for num in elements. If num -1 not in elements, so I'm checking that this is a start, right? Start of a sequence. And if it is the case, then what can I do? Then I can actually, I need to have the answer. So answer is gonna be minus float of infinity. No, answer is 0 actually. The maximum length is 0 for num and nums. So I can just return answer here. If num -1 not in elements in the elements, then it means it's the start of a sequence. So I can start a counter and while and the current is going to be the current number, and while current +1 in elements, I can say that I don't need a count actually. Oh, no. Yeah, I do need. I don't need a counter actually here. While current +1 is in elements, I can say current plus 1. So what I'm doing here, I'm starting from the num and I'm checking if the next one is there. If it is there, I'm adding it. And I'm iterating over it. So for example, if 1 is, I'm starting from 1, right? 1 is in there. 1 + 1 is 2, is there? Yes, so it's becoming 2. Then 2 + 1 is 3, is in there. Okay, 3 is there. And if it's in there, current becomes that 1. Yes. And answer is nothing other than maximum between current minus num plus 1. That's the length of the subsequence of the sequence, right? And answer. So let's now test this one with the second example here. So I first create the set. So I will have 0, 1, 2, 3, 4, 5, for the sake of I'm representing them in this order, but it's a set. 7, 8, 9. There's no 9. Okay, there's it. There we go. And then this is a set, so there are now duplicates. And I'm iterating over 0 for over these. Let's say I start with 6. If num minus 1 it's in there, so I'm just leaving this out. 5, yes, same. 3 does have to. Then we start with 0. And 0, and while current plus 1 is in elims, we do current plus equal plus 1 and make it current. So 1, 2, 3, 4, 5, 6, 7, 8. We end up here. Current minus 8 minus 0 is 0, plus 1 is 9, so the length is 9. Now let's run this here. Yeah, it worked. Let's try to submit this one. That's it. It works. And as expected, the time complexity here is O of n, because this one is actually done. We will be visiting each number only once, actually, because we are looking for the start here, and if not, we just avoid them. And from the start, we go to the end, and these numbers are not revisited because these are connected sequences. These are connected. It's a graph where all the components are not are separated. Space complexity for this one is O of 1. There's nothing. Oh, we're actually having a set here, so it's O of n. That's it.